We get a lot of questions about Magnaflux particle inspection and just what's happening and the theory behind it and why we do this. Mag particle inspection, or commonly referred to as Magnaflux, is a type of non-destructive testing. And what we do is we take a ferrous part and we turn it into a magnet. And then we take material that's held in a suspension and we douse the part completely as we're magnetizing it, and it creates a north and a south pole where there's a discontinuity in the part. That we can see with the black light. You can see this is a crankshaft, and you can see that we've Magnafluxed it here in this plane, and this is actually about to come apart. This crankshaft's about to come in half, and we were able to catch it and report to the customer prior to servicing it or doing anything else to it. So that would be scrap. So here we have this crankshaft between two headstocks. And what we're doing here is we'll magnetize the shaft as we douse it with this ferrous material. And as we do that, we're creating a magnet. Now, the part needs to have length and width, and it needs to be ferrous also. In this case, we're introducing a hysteresis loop that goes back and forth between these two, and will show indications 90 degrees to the axis of that hysteresis loop. Alternatively, we can use this coil, and we would douse it again and bring the coil across the part as we charge it with the circular hysteresis loop. Will show indications that are lengthwise. Our challenge when we're inspecting a crankshaft like this is to be able to tell the customer what the source of the problem was. So was it manufactured into the part and it's been there the entire time, say a forging lap or a casting line, or was it the result of stress in the part? So sometimes we can see certain failure modes that exhibit themselves based on how we're doing the Magnaflux particle inspection. Circular load or torque in the crankshaft, or the flexing of the crankshaft, is often shown indications or cracks in this radius area, much like this crankshaft here. We speculate that this probably had a sudden stop at this gear area in the back, probably locked up, and the rest of the engine tried to continue to turn, and it created that indication that we're seeing here in this crankshaft. When we see heat, often we see heat as a thermal expansion crack and then a quenching of that. And so we'll see cracks lengthwise. And so we can know, then further we'll check for hardness and other things that will tell us whether or not we can remanufacture this crankshaft. Typically the depth of the crack is similar to the length of the crack. So if we see a 1/4 inch long crack, it's likely to be a 1/4 inch deep. And so our goal here is to give the customer good information about the condition of their part. To demonstrate that we've actually turned this part into a magnet, we here have used the coils, and we're giving this coil shots down the length of the part. So what that's doing is that's giving us a hysteresis loop that goes circular, which will show us linear indications. To demonstrate this theory, we can actually use this magnetic field indicator. Now that we've charged this part, we can see that the field indicator shows a positive charge, and at the other end of the crankshaft, it will show a negative charge. So this crankshaft has a north and a south pole. Once the inspection is complete, we demagnetize the part. And you can see the amps. Once the magnetic particle inspection is complete, we demagnetize the part. We do this by running the coil across it, demagnetizing the part, and we can check with the field indicator, and it should show close to 0. So now you can see that the part is no longer a magnet and will no longer hold ferrous material to the crankshaft. We hope this answers some questions about magnetical particle inspection, why we do what we do, and the magic of Magnaflux we find when we're checking for cracks. Thank you.